So far, you have heard the name of so many thermodynamic processes, such as constant pressure process, constant volume process, constant temperature process, etc. Now, in this class, I am going to discuss a process which is known as quasi-static process. Quasi-static process. Quasi means semi or as if. Means quasi-static means apparently it is static. Actually, this process is neither static nor dynamic. Okay. Neither static nor dynamic. This is why this type of name is given quasi-static process. So quasi means here semi. You can see in the video that there is one cylinder and piston arrangement. So inside the chamber of the cylinder, inside the chamber there is some gas kept at certain condition where pressure, volume, temperature, these are given by P1, V1, T1. You can see in the image. Here pressure, volume and temperature are given by P1, V1 and T1. And you can see that some weights are kept on the top of the piston. Some weights are given. Now it is in static condition. Gas inside the chamber is exerting pressure in the upward direction, and the weights, these are applying pressure or exerting pressure on the piston in the downward direction. So how much is the pressure of the gas which is being exerted on the piston? It is equal to the total weights which are kept plus the weight of the piston itself. Okay, weight of the piston plus the extra weights, that total weights divided by the internal cross-sectional area of the cylinder is the pressure which is being exerted by the gas on the piston. Okay. Now total force exerted by the gas in the upward direction is equal to the total force exerted by the weights plus the piston in the downward direction. Both are same, and this is why they are in equilibrium condition. They are not moving. Now, so for example, if we add on some weights on the piston, some extra weights on the piston, if we add some weights, what will happen? So there is extra force applying in the downward direction after putting the weights. So there will be some downward movement of the piston. Okay, there will be some downward movement of the piston. So what will happen? The volume of the gas will decrease. Since the volume of the chamber will decrease, so volume of the gas will decrease. And pressure will increase since there is extra weight, and you know that pressure is equal to total weight divided by the area. Area remains same, so due to extra weights, pressure will be more. Pressure will increase. So now in this condition, pressure is more, volume is less. And due to the movement of the piston, there is a chance of heat being generated. So if heat is generated, there will be some rise in temperature of the gas also. But in our this thought experiment, we are not going to conduct this experiment practically in laboratory. Okay, it is just an thought experiment. Suppose frictional effects are absent. When the piston is moving inside the cylinder chamber, frictional effects are absent. There is no frictional force. Okay. And also we have added weight, extra weight on the piston. Suppose that extra weight is too small. It is infinitesimally small quantity. Say weights are denoted by W and these small weights are denoted by delta W, which is very small quantity. If the extra weight is very small quantity, so you know that after putting that extra weight, there will be very little downward movement of the piston. Okay. Say downward movement is denoted by X. So here that little movement will be denoted by delta X. So that delta X is actually very small. Okay. And after putting that extra weight delta W, wait for some time. So if you wait for some time, the system again will reach in equilibrium condition. Equilibrium means thermodynamic equilibrium condition. And you know that to achieve thermodynamic equilibrium, three conditions must be satisfied. Those three conditions are mechanical equilibrium, chemical equilibrium, and thermal equilibrium. You know all these things. If all these three equilibrium conditions are satisfied simultaneously, then only we can say that the system is in thermodynamic equilibrium. So after adding that extra weight, there is little movement of the piston in the downward direction and we will get new values of pressure, volume and temperature. Say these new values are denoted by P2, V2, T2, etc. like that. Or say P1 dash, V1 dash, T1 dash. It is your choice, whatever names you make. Assign it. Okay. So you have got one extra point. On the graph paper, now you can denote this second point, which are denoted by P1 dash, V1 dash, T1 dash, etc. In the right hand side of this cylinder, piston cylinder arrangement, you can see one graph, pressure versus volume graph. Pressure is vertical and volume is horizontal. And you can see that there is one graph. There is one curved line. The initial state is denoted by 1 and the final state is denoted by 2. And you know that to draw the required graph between the points 1 and 2, you need to know all the intermediate points. You need to know all the intermediate points. If a relationship is available, mathematical relationship available between P and V, pressure and volume, then you can easily draw the graph. But in our case, this relationship is not available. Relationship between pressure and volume. If it is not available, then how you will draw the graph? Then in that case, you have to know each and every point of the graph or of the curve, each and every point of the curve. But it is impossible. Because you know that between any two given points, there are infinite number of points. So instead of getting infinite number of points, if you want to draw a smooth graph, at least few points should be there. And you know that if number of points is large, then you can draw a smooth graph. So for example, in our thought experiment, you say, you just assume that we need 1000 number of points to reach from 1 to 2. Then we have to add so many number of weights, one by one. First put one weight, then wait for some time. You will get new values of pressure and volume. Mark that point, okay, on the graph. Then again, you add one more weight, again you will get new volume, new values of pressure and volume. Then again you mark that point on the graph. This way if you approach, you will finally reach to point 2. So it is for experimental procedure. But for our thought experiment, there are infinite number of points. So you know that if there are infinite number of points between 1 and 2, state 1 and state 2, then time required to do this experiment will be infinite. So required number of points will be infinite if you do the thought experiment. And in that case, required time will be also infinite. Okay. So this thought experiment is required to get an idea about quasi-static process. This video has already become so large. Memory is in my mobile is not supporting longer videos. So this video will be marked as part 1. Just after some time I'll post one more video which will be part 2. That will finish the lecture on quasi-static process. Okay. So this lecture will be continued in the next video. Thank you.